So today we are discussing calendar problem. Calendar related problem in CSIR-NET exam, it have not asked frequently, but they have asked one time or the other. So the last time they have asked one question. We will start with that and teach you more theory after this, because this is a so straightforward question that you can do directly. Okay, we'll start explaining. What day of the week will it be 61 days from a Friday? So these kinds of questions, just think from today. Just imagine today is a Friday. If today is a Friday, 7th day from today is a Friday. 7th day, if this is today, today is a Friday, so 7th day also will be Friday itself. 14th day will be a Friday itself. 21st day will be a Friday. Why? After every 7 days, the days will repeat. The day will repeat. For example, if today is 15th of November or 15th plus 7, 22nd day will be the same day itself. If today is Sunday, 22nd day also is a Sunday. Because after 7 days, the day repeats. That means if today is a Friday, 7th day is a Friday, 14th day is a Friday, 21st day is a Friday, 28th day is a Friday, 35th, 42, 49, 56. Like that you can just think 61 days, 61st day is what we want to know. 61st day means you can reach 63rd day. That is easy because 63 is a multiple of 7. So 63rd day is a Friday for sure if today is a Friday. If 63rd day is a Friday, you can easily calculate 62nd and 61st easily. So 62nd day will be what? 62nd day will be Thursday and 61st day will be Wednesday, because 2 days before 63rd will be 2 days before Friday, that is Wednesday. So option D is the answer. Some of you may have done 56th day first and then counted 57, 58, 59, 60, 61. But that takes more time because you have to count 5 days forward. You can save a little bit more time if you are going for 63rd and then going backward. So multiple of 7 is the concept. In general, calendar problem, the most important things I have summarized. In a normal year, there are 365 days. And 365 days, if you split it up, that is 52 complete weeks. Complete weeks means 7-day complete weeks. And 1 day extra. Why 1 day extra? Because if you divide 365 by 7, quotient will be 52, remainder will be 1. That means 1 day extra. That day is called odd day. The definition of odd day is given. In some other questions we need this. That is why I just told the definition of odd day. Number of days more than the complete weeks. In a normal year, 365 days, 52 complete weeks will be there and 1 day extra will be there. That 1 day is called odd day. Now for a leap year, as you know, leap year have 366 days. Leap year is a year where February have 29 days or 1 extra day is there. 1 extra day is there means compared to the ordinary year, 1 extra day is there. But if 366, if you just divide 52 complete weeks and 2 extra days will be there. 2 odd days will be there. 2 extra days. That means why this 1 day, 2 day are needed? This is how a calendar year, a day of week shift. For example, if this year 15th November is a Sunday, next year 15th November will be a Monday. That 1 day shift is happening because ordinary year have 1 day extra. If it is a leap year in between these 2 years, 2 day shifting will be happening. For example, last year 2019 if 15th November will not be a Sunday, it will not be a Saturday, it will be a Friday. Why? 2020 is a leap year, February 29 is coming. So, if you consider 15th November 2020 to be Sunday, 1 year backward, if you consider 1 year backward 15th November itself, if you consider the same 15th November, in 2019, 2020 is a leap year, that means between these 2 years, a February 29 is coming. February 29 is coming means 2 days extra is coming. 2 days extra is coming means 2 day backward. Why backward? Because 2020, 2019 is a year before. So 2 day backward means that will be a Friday. This is how to calculate, because odd days in ordinary year is 1, that means 1 day shifting forward or backward. Odd days in leap year is 2, that means 2 days shifting forward or backward. Again, I will write it again, 15th November 2021 if you want to find. That will be not a Sunday, that will be a Monday. Why? 2020, 2021, only a complete ordinary year only comes. February 29 is not coming, because the February that is coming is of 2021. 2021 is not a leap year. So February 28 days only are there. So 365 days year it is. That means 1 day shifting only. This is a basic theory you should know about calendar. And next thing is how to identify a leap year. That is another thing. I will briefly explain that also, so that the upcoming questions we can discuss faster with this theory itself. So, because all the question may not be this simple, what is the next 61st day or 52nd day? If question comes like that, very good, but always it may not be like that. So that is why identification of leap year is a very important thing, because in school days we had many misconceptions about it. Many of us have learned it that in every 4 years there is a leap year, but that is a completely wrong idea. In every 4 years there is no leap year. Most of the time there is a leap year in every 4 years, but sometimes there is no leap year in 4 years also. That is when a century is coming. That condition, if you are not aware, please learn it. If the particular year is a century, that number should be divisible by 400 to be a leap year. I will explain what does that mean. Look at this example, 884. 884 is a multiple of 4. To check a multiple of 4 in numbers chapter, we learned the theory. Last 2 digits, that is 84 is a multiple of 4. So 884 is also a multiple of 4. Divisible by 4 means multiple of 4. Exactly divisible, that's the meaning. That means 884 is exactly divisible by 4. That means that is a leap year. That means that will have 366 days. 1564 also leap year, because 64 is a multiple. About 1600, 2000 I will explain. 2012, 12 is a multiple of 4, so 2012 is also leap year. In those cases it's okay. Only when the year is century there is an exception. Century means ending in 00, last 2 digits 0, or multiple of 100. Na? Every multiple of 100 by default will be divisible by 4 itself. You don't have to check it again, because if 100 is factor, 4 is by default a factor. Why? Because 100 is 4 into 25. So for a non-century, you only have to check whether it is divisible by 4. For a century is already divisible by 4. So you don't have to check divisibility by 4. You have to check divisibility by 400. That is an exception you should learn. If you are not already aware about it, please learn it now. For a non-century, divisibility by 4 check is okay. For a century, divisibility check by 400 is needed. I will tell you what does that mean. For example, 2200, it is a multiple of 4. But even if it is a multiple of 4, it is not a leap year, it is an ordinary year. Why? Because it is a century, and the century is not divisible by 400. Divisible by 400 means 2200 divided by 400. You should not get a remainder. No, you are getting remainder. It is not exactly divisible. That is the idea. So, 2200 is not leap year by that reason. Only for centuries this problem arises. So, if I summarize it, 100 is not a leap year even if it is a multiple of 4. 200 is not a leap year even if it is a multiple of 4. 300, year 300 is what I am saying. It is not a multiple, it is not divisible by 400, so it is not leap year. But 400 is a leap year because 400 is divisible by 400. 400 by 400, quotient is 1, remainder is 0. 500 not a leap year. Why? Because 500 is a century. For century the second criterion should be applied. It should be divisible by 400. 400 into something. That something cannot be a natural number to make it 500. So it is not a leap year. 600 not a leap year. 700 not a leap year. 800 will be a leap year. 900 not a leap year. 1000 or 1000 not a leap year. 1100 not a leap year. 1200 yes. Now you got the pattern. In every 400 years, The 4th century is a leap year, other centuries are not leap years. 1300 not a leap year, 1400 not a leap year, 1500 not a leap year, but 1600 yes, it is a leap year. That is why 1600 I have placed it here, because 1600 is 400 into 4. 2000 is a leap year then. 2400 is a leap year. So that is the idea. Now you may be thinking that why these twists and turns, or why these complicated way this calendar problem is set. Is it because the calendar problem should be difficult, that is the reason? No. It is because that is how Earth behaves. What is this year? Literally, what is year? Year is the time taken by Earth to revolve around the Sun. That means that takes 365.25. That is what we are assuming. That is why we think that only one first condition is there. But it is not 365.25, it is 365.2476. 2476 recurring. This 2476 we are approximately taking it as 365.25. 25 is quarter. That is why we say that quarter adds up 4 years and make a leap day. That is why on the 4th year we extra add a day. Because quarter, 1 day full. That 1 day full will be 1 extra day. That is why February 29 on the 4th day. But the problem is this 0.2476 we are approximating it as 25. There is an error we are making now. To avoid the error, the second criterion we are fixing. VR means when the calendar was fixed by all the nations, or this is called, the calendar we use now is called Gregorian calendar. 1600s is when this Gregorian calendar came to use, but some countries did not accept in that century. Some countries even accepted only in the 20th century. Before that, the calendars were not same all over the world. So anyway, so countries decided that this 0.2476, that will be confusing because this is not 6 hours completely. 0.25 is 6 hours. 1/4 of a day means 6 hours. But 0.2476 is little less than 6 hours. Maybe 5 hours 59 minutes, for example. That 5 hours 59 minutes, 5 hours 59 minutes in 4 days, that will not make one whole day. But that February 29 not having 24 hours is not practical. Only for 1 day changing the time or clock is not practical. That is why when the calendar was fixed, it was decided that we will sort out the error later. So mathematically they calculated and decided that in every 400 years you have to skip 3 days to rectify this error. So 3 days wanted to be skipped. So we decided that in every 400 years, let's skip the 1st century, 2nd century, 3rd century from the leap year, so that the count or the time does not vary at all. Still there is actually an error. Leap second, that is called leap second. I think that is adjusted after about, exactly I don't know, 32 years or something. There is one more adjustment done with 1 second or 2 seconds. That you can Google more about it. What is leap second? Even this correction that in every 400 years, 3 days completely, that correction is also not enough. Due to that, leap second error comes. That also, it's an interesting topic to learn. Anyway, right now we are fixing like this. In every 400 years, 1st, 2nd and 3rd century we are skipping. That is why the second criterion. Once you understood the criterion, you can learn it mathematically that if it is a century, you should check whether it is divisible by 400. If it is a non-century, you just have to check with divisibility by 4 only. So that is about leap year. Now how that will affect, look at this question. This question is exactly asked to check whether you know what I taught you now. All of you try this. December 2013 CSIR-NET exam, this question came. Okay, we'll start explaining. If a 4-digit year is chosen randomly, what is the probability that it is not a leap year? Not a leap year means ordinary year. An year with February having only 28 days. So this concept is again coming into play in this question also. As I told, the second criterion you should understand. This question is checking that only. In every 4 consecutive years, there should be one multiple of 4. That means there should be a there should be a leap year by that condition. But as I told, second criterion makes an exception. So by the first criterion we understood that by the first criterion the default probability should be 3 by 4. In every 4 year, 3 ordinary year, not a leap year means ordinary year. 3 by 4 should have been the probability if you only consider the first criterion. But if you consider the second criterion also, in some set of 4 years, one of the leap year is deleted. I mean, the leap year available there is deleted. That means all the 4 years consecutively will be ordinary years itself. For example, if I take 1899, 1900, 1901, 1902, these are 4 consecutive years. There is not even one leap year in this, because the only number which can be a leap year is 1900, because it is a multiple of 4. But as it is a century, the second criterion is applicable. It should be divisible by 400, but it is not divisible, so this is not a leap year. So this is an ordinary year, this is an ordinary year, this is an ordinary year, this is an ordinary year. Yeah, for your information, 1902 is not a multiple of 4, it is only a multiple of 2. So all these are ordinary years. All these are ordinary years means 4 out of 4 is the probability of getting ordinary year in these kinds of set. Generally 3 out of 4, now 4 out of 4. Most of the time 3 out of 4, sometimes 4 out of 4. That means total probability little more than 3 by 4 na? Because it can never be less than 3 by 4. It will be 3 by 4 or 4 by 4. So as an average we find little more than 3 by 4 will be the probability. I hope all of you are understanding this. Greater than 3 by 4 because of the second criterion. If only first criterion was there, 3 by 4 exactly would have been the answer. But second criterion makes it greater than 3 by 4 as the answer. That is option D is the correct answer. Not a leap year is the question. If the question was leap year, then option C would have been the answer. Here the question is not a leap year, that is why greater than 3 by 4 is the answer. So, as I told, this question is plainly checking whether you know only one criterion for leap year or whether you know both the criterions for leap year. Try the next question. So let's see, what is the maximum sum of the number of Saturdays and Sundays in a leap year? As you know, leap year means 366 days. 366, as we found it, it is 52 complete weeks and 2 extra days. 52 weeks na? 52 weeks will have how many Saturdays and Sundays? Every week will have 1 Saturday, 1 Sunday. That means 2 in total, Saturday, Sunday together, 52 into 2, 104 would have been the answer if you don't consider this 2 days. Now the question is asking maximum, that means you can take a best case scenario when you can make these 2 days as Saturday and Sunday, and that is totally possible. 104 plus 2, 106 is the answer. Now if you are thinking how it is possible, just take the first day of the year, Jan 1 as a Saturday. If Jan 1 is a Saturday, you are completing 1 week on Jan 7th, that will be a Friday, completing 1 week. Like this, 1 week, 2 week, 3 week, 4 week, up to 52nd week when you complete. 52nd week when you complete, that will be completed on a Friday. And if you check the day, that will be December 29. Because 366th day will be the last day of the year, December 31st. December 30 will be 365th day. December 29 will be 364th day, which is the last day of the complete 52nd week. That means when December 29 is completed, you are already completing 52 Saturdays and 52 Sundays as we mentioned here. Now still 2 more days remaining, December 30 and December 31. That will be what? After Friday comes Saturday, Sunday. So as it is a leap year, only because question says it's a leap year, the answer is 106. If it was mentioned ordinary year, 105 would have been the answer because 1 odd day only. This is the again one more significance of odd days. If the slide is working, I will show you. if you are just starting Jan 1st, Jan 1 with a Saturday, Jan 2 a Sunday, then 29 December will be a Friday itself, 30th December will be Saturday, and there is 31st December also. 31st December will be a Sunday for sure. So 30th and 31st is Saturday, Sunday means 2 additional Saturday, Sunday you are getting. As the question is asking maximum, that is the answer. Actually, in this question, more than calendar concept, your skill of making an equation and solving an equation is more needed. But number of days in every month is needed for doing this question. So I will explain. A certain day which is X days before 17th August. So we will try to draw a timeline. 17th August is a day which is mentioned in the question. Another date it is told is March 30th. So 30th March is another date. 30th March. So between these two dates, we are told about some special days. Days we are mentioned. A certain day which is X days before 17th August. So before 17th August, X days before there is a day. I will call that day as A. Day A. Day A and 17th August there is X days before it. So I am drawing a timeline like this. Is such that means that day A is such that, that's a meaning. 50 days prior to means before. 50 days before A, 50 days before this day A, there is a day. I will call that day B. So distance between B and A will be 50 days. That is the meaning. 50 days prior to that day. That day means the day A. It was means the day B was 4x days since March 30th. Since means after. Since, hence, those kinds of words when you see in a question, understand it, it is after. Prior means before. It was 4x days since March 30th. That means it is 4x days after March 30th. So this is going to be 4x. Then what is x? Now it is very clear after this timeline, I guess. 30th March to B date is 4x days. B date to A day, 50 days. A day to 17th August, x days. These three values added, you should get the total number of days between these two. That you already know because you know the calendar. 30th March to 17th August, how many days are there? That will be equal to sum of these three partitions. So that you have to calculate. Yeah, 30 days of September, April, June and November, you know that song, I guess. So March have 30 days. After 30th March means 31 only you will count. So 1 day in March. Now April have 30 days. April have 30 days means that whole 30 days you have to count. Because you have to reach August 17th. So April is coming in between. May is coming in between, which is having 31 days. June is having 30 days, you have to add that also. July is having 31 days, add that also. August is having 31 days, but we need to reach 17th August only. So 17 days only we need. So the number of days between, I am just giving a random calendar and saying. So, but in every year, March to August, there is no difference at all. If there was February, then confusion could have been there. Because leap year or non-leap year, that will depend. But here it's February is not coming, that is why whichever year it is, I just took an example of 2018 calendar, whichever year it is, this will be the number of days between the particular two dates. So if you add it up, you will get 140. That means 140 is the number of days. So this is what I just told. 0th day and 140th day, you have three things in between. 4x, 50 days, x days. Just think it as distance. For example, you want to go from Delhi to Agra. You have three stations in between. Delhi to, for example, any 3 dates you can, or Delhi to Mumbai you want to go. There are 3 spots in between. Delhi to Agra, Agra to Goa, Goa to Mumbai. That means Delhi to Agra distance, Agra to Goa distance, Goa to Mumbai distance, if you add up, technically you should get the total distance. Same here, it is about days only. So 4x plus 50 plus x equal to 140. That is what you are going to. We got an equation. Now you just have to solve it to find the value of x. 5x equal to 90, x equal to 18. So x equal to 18. This is how to do that question. If so, try the next question. A calendar concept needed here is only January have 31 days. This is a purely logical question which came in June 2017 CSIR-NET problem. Listen very carefully. My birthday is in January. So if your birthday is in January, you can easily imagine this, or any month it is okay. 31 days are there in January. So a 31 day month, whichever it is, it's okay. Even if it is not 31 day month also, it's okay. What would be the sufficient number of questions with yes or no answers only that will enable one to find my birth date? So here the idea of iteration we are going to do. I will show you how. So I am just, for example, for making you understand this clearly, I will just take an example of a date called Jan 7th. Jan 7th. I don't know before whether it is Jan 7th is the birthday of that person, but with questions I am trying to find it is Jan 7th. Without knowing anything about the birthday, only knowing that it is in January, I can ask these 5 questions and 5 will be the answer. Listen carefully. This is the first question. So here the idea is this 31 days you have to divide it into 2 as much as possible equal parts. 31 is an odd number, that is why you can only divide it as 16 and 15. That means 1 to 16 I can divide, then next 15 dates, that is 17 to 31 I can divide. And I can take any one half of it. That means I will ask first question number 1 is it between Jan 1 and 16? Is the date between Jan 1 and 16? I can only ask yes or no question. It's like an interesting game. So the person can say yes or no, but here as the person's mind, he have Jan 7th in the mind, he will say yes for sure. If he say no also, it's okay. Then we will understand that the date is not between Jan 1 and 16. So yes, he told means we deleted this half. Now you only have 16 days. That 16 you again divide. How? Into 2 equal halves. 1 to 8 and 9 to 16. Half. Take any one of the half. Any one half you can take. I will just take Jan 1 to 8 and ask, is the date between Jan 1 to 8? He will say yes if the date is Jan 7. Again, I am taking only an example of Jan 7. You can replace it by any other example and try this. Or if your siblings' birth date is in January or not in January, any month, try this on them. Or try it on your relatives or friends. So third question, as you got it is yes, you deleted this half. Now 1 to 8 again I am dividing. 1 to 4 and 5 to 8. 2 equal halves. So I will just ask any one of it. Is it between Jan 1 to 4? The person will say no because it is Jan 7th. So it is not between Jan 1 to 4. As it is no, what we understood. 1 to 4 is not the value. So 5 to 8 is the possibility. So 5 to 8 you have to divide it into 2 equal parts. 5 to 6, 7 to 8. 5 to 6 or 7 to 8. 5 to 6 means 5 or 6, that's all. Because 2 values only are there. Na? So the fourth question is Jan 5 to 6. 5 to 6 means 5 or 6. Is it the answer? No. He will say no because Jan 7th is the birth date. So the fifth question will be, now what is the meaning of a no? We understood that Jan 7 or Jan 8. So the next question is either Jan 7 you can ask or Jan 8. Is it Jan 7? That is not what we are saying as the date. That is a question, final question. Is it Jan 7? He will say yes. If he say yes, we have found that the birthday of the person is on Jan 7. If he say no, we found that the birthday of the person is Jan 8. With the example I started, he will say yes only. That means 5 questions are needed. Whichever month, this is the idea. If it is a 30-day month, you have to divide 15 and do the procedure, and you will realize that also need 5 steps itself. If it is February also 5 steps are needed. It is the idea of 2 raised to 5. 31 is actually below 2 raised to 5 now. Every question take it into half. So 2 into 2 into 2 into 2 into 2, 32. If the number of days were above 32, then you may need 6 questions. Because then it comes in the range of 2 raised to 5 to 2 raised to 6. But every year, every month have less than 32 days now. So it will be always 5 days only, even if the 5 questions only, even if the question was not saying January, even if the question was saying January, February, March, whatever month, this is the case. So let's try the next question, June 2014 CSIR-NET problem. The odd day concept is very needed. For a leap year, 2 odd days, 2 odd days after in 366 days. Odd days means extra days. I told you. In ordinary year, 1 odd day only. 1 odd day only. So that concept, if you know, you can do it very easily. So November 9, 1994 was a Wednesday. Then which of the following is true? Listen very carefully. If you are not thorough with this concept, listen very carefully. I will explain. November 9, 1994 is a Wednesday. Now, if you look at all the 4 options, it is asking about November 9, 1970 and 1965. November 9 itself, that is why you can easily do it. So, there are complete years. How many complete years? First, we will consider 94 and 70. 94 and 70, how many years are in between? 24 years are in between. 24 years. 94 minus 70, 24 complete years. As it is November 9 itself, complete years are there. I told you odd days in an ordinary year 1 odd day, in a leap year 2 odd day. That is what is creating shift. Whether it is Wednesday itself, that means no shift should be coming. No shift should be coming means 7 odd days in between, or 14 odd days in between, or 21 odd days, then only it can be Wednesday itself. Otherwise it will be some other day. So we have to know in this 24 years how many odd days are there. For that 24 years, how many leap years are there, first you have to find. In every 4 year, 1 leap year is there. Na? So in 24 years, 24 by 4, 6 leap years should be there. That is the idea. Yeah, here I said in every 4 year, 1 leap year, because there is no century coming in between. Only when century comes, there is an exception that in every 4 year, 1 leap year is not there. But 94 and 70, there is no centuries at all. So by default, 24 by 4, the quotient 6. 6 leap years should be there. Every leap year will contribute 2 days. As it is going backward, 2 day backward. 6 leap year will contribute 6 into 2, 12 day backward. 12 day backward from Wednesday. Now 6 leap years and the remaining are ordinary year. Remaining means 24 minus 6. 24 minus 6 is 18. 6 leap year and 18 ordinary year. Because which are not leap year are ordinary. Na? Ordinary year have 365 days, that means 1 odd day only. So 18 ordinary years have 18 into 1, 18 odd days only. So 6 into 2, 12, 18 into 1, 18. 12 plus 18 is 30. So total 30 odd days will be there. Odd days, I told you, they are extra days after complete weeks. Extra days after complete weeks means what? 30 odd days is same as 2 odd days. Why they are same? Because multiples of 7 does not matter in a calendar problem, because multiples of 7 will give you the same day only. 30 day backward and 23 day backward and 16 day backward, 9 day backward, 2 day backward, all are same. If you just think that 2 day backward is same as, if 2 day backward from Wednesday is a Monday, 9 day backward from Wednesday is also Monday, because between 2 and 9, 7 days are there. 7 days will not change the day. That means it will come again the same Monday itself. 16 days also Monday itself. 23 days also Monday itself. 30 days also Monday itself. Or simply speaking, 30 mod 7. Mathematically speaking, that is called 30 mod 7. Mod 7 means when you divide by 7, take the remainder. Remainder is 2. That is the extra days. Or that is the total shift that is happening. Total shift means 94 November 9 is Wednesday means 1970 November 9 will not be Wednesday. It will be 2 day backward. 2 odd day means 2 day backward. Why? Because 94 1970 is an year before. 2 day backward means it will be a Monday. It will be a Monday. So we understood that 1970 November 9 will be a Monday. Now 1965 you need. If November 1970 you got Monday means you can calculate backward also, no problem. 69 because there are not many years. 69, 68, 67, 65, 66 and 65. 1 day means ordinary year 1 day backward. So Monday will become Sunday. 68 is an ordinary year or a leap year. It is a leap year. But you only have to shift 1 day backward because February 29 is not coming in between these two. Because we are considering November 9. November 9, 1969 and November 9, 1968. February 29 of 1968 is not coming. That is why we don't have to worry about it. But November 9, 1967 and 1968, in between that, February 29 of 1968 is coming. That is why 2 day shifting will happen. Saturday 2 day shifting. It is not Friday. It will be a Thursday. November 9, 1966, 1 day shifting only because not a leap year, ordinary year. 65, 1 day shifting only, Tuesday. 1 day shifting only. That means 1965 November 9 will be a Tuesday. 1970 November 9 will be a Monday. So the option which is saying not a Tuesday, not a Wednesday will be the answer. Option D. 1965 is also not a Wednesday, 1970 is also not a Wednesday. I know this is little time consuming to calculate all this. CSIR only one time they have asked question directly saying dates and finding the day. But if you practice, you can speed up this. So I am again summarizing. Find the years in between. How many leap years are there? That into 2 you have to do. How many ordinary years are there? That into 1 you have to do. That will be total odd days. Total odd days decides how many shifting should be done. As the year is 1 year before, so that many shifting. But if the number of years are less, you can manually count also. This is manual counting example. Because 1970 and 65 only 5 years are in between. Here also you can mathematically count also. How? 70 to 65, 5 years now. In that 5 year, 1 leap year and 4 ordinary years. 1 leap year means 2 odd days. 4 ordinary years means 4 into 1, 4 odd days. So total 6 odd days. 6 odd days from Monday will give you Tuesday. That way also you can do. Because 7 days shifted from Monday backward is Monday itself. 6 days shifted will be 1 day after Monday, Tuesday. If that is clear, this is the last question. This was also a CSIR-NET problem itself. What is the minimum number of days between one Friday the 13th and another Friday the next Friday the 13th? Assume the year is a leap year. So that means February have 29 days. Here also you have to start some assumptions. I will just think Jan 13 is a Friday. So that we have something to start with. Jan 13th is a Friday means whether Feb 13 can be Friday or not, that is what the question says. If Feb 13 is a Friday, how many days are in between this? That is the question asking. For the same day of the week repeating, there should be a multiple of 7 in between. Last question also we did that itself. 365 is not a multiple of 7, that is why calendars don't repeat. Repeat in next year. Same way in month wise also, Jan 13 and Feb 13, if you count the number of days in between, 31 days will be there in between. Why 31? Jan 13 to Jan 31st. Then Feb 1 to Feb 13. That means if you arrange them 1 to 13, 14 to 31, total 31 days will be in between. 31 is not a multiple of 7. 28 is a multiple of 7. So there are 3 days extra. So this is not going to be a Friday. This is going to be 3 days extra. Saturday, Sunday, Monday. This is going to be a Monday. So definitely 31 cannot be the answer, or minimum number of days between one Friday to 13 means February 13 is not a Friday if Jan 13 is a Friday. We are assuming that Jan 13 is a Friday and checking whether Feb 13 can be a Friday or not. Feb 13 cannot be a Friday because there are 31 days. 31 is not a multiple of 7, because multiple of 7 only you can get the same day of the week, because there are 7 days in a week. Now you just think about March 13, can it be a Friday? Feb 13, March 13, 29 days are there, because February have, so February will have 29 days as it is a leap year. As it is a leap year, it will have 29 days. 29 days means from Jan 13, March 13 will be a leap year or not, that is what we want to find. So Jan 13, March 13, number of days will be 31 days plus 29 days, total 60 days. 60 is not a multiple of 7, 63 is a multiple, 56 is a multiple, 60 is not a multiple. That means there is no chance to get a Friday again here. What day if you want, you can just find 60. 56 plus 4 is 60. So 4th day from Friday. That way you can imagine that is Tuesday. So March 13 is also not a Friday. Now April 13, can it be a Friday? April 13 means March to April number of days is 30 days. Sorry, 31 days, because March have 31 days. March 13 to 31, 1 to April 1 to 13, so total 31 days. So total number of days will be 31 plus 29 plus 31. 31 plus 29 plus 31 means Jan 13 to April 13, there will be 91 days. There will be 91 days there. 91 days, 91 is a multiple of 7. 91 is a multiple of 7, that is 7 into 13. As it is a multiple of 7, same day of week will come. Friday means this is also a Friday. Again, little time consuming to understand this concept. Once you got the concept, it is very simple actually. So Friday it will be, and that is what we need. Number of days between one Friday the 13th and next Friday the 13th. So if Jan 13 is a Friday, provided the year is a leap year, question says it is a leap year, then April 13 only can be a Friday. Between that Feb 13 and March 13 will not be a Friday, because there is not a multiple of 7 in between if you calculate the number of days in between. That is why how many days, which month is not the question, how many number of days are there? 91 days should be there. Because Jan 13 to April 13, 91 days are there. So option C is the answer. I know the last two questions are little tough to understand. The remaining questions are actually easy. These slides will give you more idea. This is what I just explained. Now you don't have to try after April 13 whether it is coming on May or June, we don't want to find, because we already found 91 as a multiple. Now if you are thinking that if you don't start from Jan 13, will you get a different answer? No. Then also multiple of 7 will not come. You can try it if you want. So option C is the answer. So that's it. If you need a homework, I have given a homework here. All the CSIR-NET questions came from this topic is done. This is just a practice question. So if there is any doubt now, you can ask it now. Prajakta asked a doubt. If leap year not mentioned, then there is change in exam. How we understand, we have to consider leap. Question will always say Prajakta. Otherwise we cannot find it at all now. Here the question is saying consider it as leap year. They will say it. Otherwise we will be confused obviously. If the word leap year was not there, I mean ordinary year was given. If nothing was given, you can take all the cases. That means ordinary year it can be considered. If ordinary year is considered, 28 will be the answer, because between Feb 13 and March 13, Feb 13 and March 13 will be the same day of the week, because there are 28 days. 28 is a multiple of 7.